Hi. So imagine you're standing in a room, okay? You're asked to move 5 steps. Just I asked you to move just 5 steps. In which direction will you move? So you'll randomly move to 5 steps, that's it. Am I correct? So if I asked you to move straight 5 steps, you'll be putting forward in the direction where you stand in front of the face. Am I correct? So you need to understand this is the basic difference between a scalar and a vector. Okay. A scalar is like a number which has no direction, but it will have a magnitude. Okay, if I ask you to move 5 kilometer, it is just the 5 kilometer, the number, the 5. It is called the magnitude of scalar. Okay, and if I ask you to move to the right in 5 kilometer, for 5 kilometer, that means you have moved. I have a specific data of which direction you have traveled and how far have you traveled. So this is more specific, this is more correct and clear. Okay, to have that clarity we introduced the concept of vector. Okay, so you don't have to get confused, you don't have to be confused when you are talking about vector quantities. Okay, so if I'm traveling to America like a superman, I would say I traveled plus 50,000, maybe 5,000 kilometers from here. Plus 5,000 kilometers is the displacement from my place where I sit in here and America, maybe White House. If I say so, that would mean from here, the place where I sit, here it is, and where this is the White House. Imagine this is White House. So the straight line from here to here, which is in plus direction and having 5,000 kilometers distance. So this is called the displacement, which is a vector quantity. What if I say I travel from America to India? So it will be minus 5,000. To understand what exactly is a vector and a scalar, you need to know that the direction plays a greater role in vector. Okay, that's it. So that is about a vector and a scalar. So which are the major vector and scalar quantities? Do you have an idea? So we have talked about displacement. So the scalar quantity analogous is distance. Yes, distance. What about the velocity? Have you heard of velocity? The light travels from here to here. This is sun and this is earth. It travels straight. It will be like a straight line. Okay, so this is a velocity, which is having a direction and a magnitude. Okay, so what if a person is traveling like this from sun to earth? We have to calculate the whole distance he has traveled to know how far he has traveled. So that is how we have to calculate the distance of the person. So acceleration, velocity, displacement, everything comes under vector quantity, and displacement, sorry, and distance, speed, that comes mass, charge, everything comes under scalar quantity. Okay, so this is about vector and scalar. So now we need to add two vectors. Imagine this is a vector from here to here. Okay, like some person is traveling from here to here. Imagine this is a vector. Okay, and I need to add another vector like this. This is a vector from here to here. Okay, I want you to add these two vectors. how are you gonna add these two vectors? Any idea? So you should, to add these, you need to understand which is the starting point of this vector and the ending point. Okay? If I say this is the starting point and this is the ending point, this is the direction. Are you clear with it? Okay. Now I have said this is the second vector. So this is the first starting point and this is the end point. Okay. In this case, to add these vectors, I have a shortcut for you. I have a very intelligent, logical shortcut for you. I'll tell you that. Imagine there is an object, this object, okay? Just imagine this is here, okay? And a vector that I told right now is pushing this object, okay? One person is pushing in this direction as this is, and the second, what I told, this one, no? This head is pushing this in this direction. So the one with greater length is having greater power or greater magnitude of pushing. Okay, so the mouse is getting pushed by this vector in a very strong way and this vector in a minor way, but in this opposite direction. So the mouse is expected to move in a direction which is not exactly like this, but there will be slightly change in this direction. So it will be traveling like this. So I'll explain one more time. So one person is pushing in this direction and another person is pushing in this direction, and this is like a tiny force and this is like a massive force. So when these two forces acts upon a body, it will act not exactly in the direction of this ball. It will be acting like this, not in straight, but it will be slightly in this direction. So this might be the resultant direction of these two vectors. So irrespective of the positions, the vectors are, if I add two vectors, it will be acting like the resultant will be like addition of both the vectors. Okay, so to calculate in a different way, in a mathematical way, this is the head of the vector and this is the head of another vector. We have to keep the head on tail. If we add like this direction will be the resultant, what I exactly told earlier. So this will be the direction. Now we got, I'll explain one more time. So this is the direction of the first vector and this is the direction of second vector. So the down point and the head, if you draw a line from here to here, starting from here to there, this will be the direction of force. Okay, so no matter which is the vector quantity, you can find the force, the direction of force with the logic of 2 or 3 forces acting on a particular body, like this. Just hit the arrows of any vectors into the object logically in your mind and just get the direction of resultant done. So you'll have to calculate the direction of vectors using parallelogram law of vector addition, triangular law of vector addition, but it doesn't matter. If you think in this way, you'll get it. Okay, so there are a lot of other ways that we can make use of these vectors, and we can find a lot of other stuffs in physics. Okay, so see you guys. Thank you.